lesson talks about volcanoes, the types of volcanoes, and the different type of volcanic eruptions. In today's lesson, there are more to learn about volcanoes. So, what are you waiting? Come on, let's learn and have fun. Meet Trisha, a volunteer of Disaster Risk Reduction Management in Metro Manila. As she watched the television,
the Taal volcano in the Philippines has thrown molten rock into the sky, triggering official warnings that a hazardous eruption of toxic gas may be imminent. Well, let's just show you some sped-up footage of a moment earlier when the plume of white smoke that's several kilometres high was then spewing up into the air as tremors shook the area. A volcanic lightning storm developed in the column of steam and ash. Pretty sensational views there. A state of calamity, as it's been described, has been declared across the province of Batangas, just south of the capital, Manila. Thousands of people have been evacuated from the area.
After seeing this, she thinks of her kababayan in Negros Oriental. She remembers that Mount Anlaon is also an active volcano in the Visayas. After weighing things, Trisha finally decided to have a vacation back to her hometown. As Trisha arrived, she immediately starts drafting her mission. Her mission is to create awareness among her townmates about volcanic hazards before, during, and after volcanic eruption. And this is what she created. For precautionary measures before volcanic eruption, we have awareness of the danger of volcanic eruption. And how can we do this? By simply observing your surroundings, listening to radio, or watching news. During volcanic eruption, it is a must to avoid all low-lying places because lava flows are more likely to pass at these areas. And for precautionary measures after volcanic eruption, wait for announcement. Local authorities may not immediately be able to provide information on what is happening and what you should do. Do not make any actions without further announcement. Now, I want you to help Trisha to search for precautionary measures to save her townmates. Write your answers in your answer sheets. Now that you're done answering our first activity and is now ready to face any adversity related to volcanic eruptions, you may wonder, why do volcanoes erupt in the first place? Notice that there are theories that can best explain this. And the first theory is due to density difference in magma. Due to heat and pressure in the Earth's mantle, solid rocks melt to form magma. Magma has the same mass as the solid rock, but more volume, making it lighter, so it will attempt to rise. If this magma continues to encounter high-density material till it reaches the Earth's crust, volcanic eruption occurs. It can be in the form of a lava flow or may be explosive. The second is pressure of released gases. Magma contains dissolved substances such as water, sulfur dioxide, and carbon dioxide. The solubility of magma decreases with the decrease in pressure as it rises up towards the crust, and the gases get released in the form of bubbles. When the volume of the gas bubbles in magma reaches around 75%, magma disintegrates into pyroclast, a mixture of partially molten and solid fragments. The bursting of pyroclast is very explosive and the cause of some of the most violent eruptions on the surface of the Earth. And the last theory is injection of new magma. When new magma enters a chamber already overflowing with magma, the volcano erupts due to the additional pressure exerted by the injection of new magma. This type of eruption can be placed or violent. Let's make it simple. The theories boils down to the term density and pressure. Volcanoes erupt because of density and pressure. The lower density of the magma relative to the surrounding rocks causes it to rise, like air bubbles in soft drinks. As the magma rises, bubbles start to form from the gas dissolved in the magma. The gas bubbles exert tremendous pressure. This pressure helps to bring the magma to the surface and forces it in the air, sometimes to great heights. To further elaborate, let's check out this video.
Alright, today we are demonstrating how a soda bottle can act like a volcanic eruption. So, comparing a magma chamber in a volcano to a soda bottle, what you have is you have an enclosed space filled with magma and various gases capped off by a cap, probably from a previous volcanic eruption. And compared to a soda bottle, we have an enclosed space filled with soda and carbon dioxide and capped by a cap. And what happens during a volcanic eruption, or just prior to one, is that the gas content within the magma chamber actually builds up the pressure within the chamber to a point when an earthquake or some other event will crack the cap. All the pressure will be released at once, and gas that's mixed into the magma will actually push that magma out of the volcano. Whereas in a soda bottle, when you open up a soda bottle that's built under pressure with carbon dioxide, what you'll get is that the gas within the soda will actually push the soda out of the cap. So, to demonstrate, we want to get a nice shaken up bottle of soda. I recommend when you puncture a cap that to do similar to a volcanic eruption, that you want to actually puncture straight into the top of the cap. You don't want to open the cap, because opening the cap will spray out the soda sideways. And also, you don't want to do like the Mentos experiment by putting Mentos into the soda, because that's just a magma chamber, which is not what you have. You just have a fluid gas under pressure, and we're releasing the pressure. So, I recommend you get this nice mixed up. Usually while I'm giving my lecture, I'll be shaking at the entire time. Nice, volatile, and what I do is push sugar straight into the cap. And we have the volcanic eruption.
When volcano erupt, materials comes out of it. It includes hot molten magma, gases, and solid rocky chunks. With this, volcanoes pose a threat to almost 500 million people. There are approximately 500 active volcanoes on Earth, and every year there are 10 to 40 volcanic eruptions. Volcanic eruptions produce hazardous effects to the environment, climate, and health of the exposed persons, and are associated with the deterioration of social and economic condition. If you are located near a volcano, hazardous effect includes pyroclastic flows, gases and steam, earthquakes, blasts of air, and tsunami. And if you are located distant places from a volcano, you might experience problems of the respiratory system, eye, skin due to volcanic ashes. Now let's highlight its negative effects. As mentioned earlier, when volcano erupt, huge amount of gases release into the atmosphere, and the most abundant gases is water vapor. Of course, water vapor is not harmful. However, there are volcanic gases that pose a great hazard to people, animals, agricultures, and properties. These are sulfur dioxide, hydrogen sulfide, carbon dioxide, hydrogen chloride, and hydrogen fluoride. Let's examine these gases one by one. Sulfur dioxide is a colorless gas with a pungent odor that irritates skin and mucous membranes of the eyes, nose, and throat. Sulfur dioxide emissions can cause acid rain, air pollution like volcanic smog, and it can contribute to ozone depletion. Hydrogen sulfide is a colorless flammable gas with a strong offensive odor, also known as sewer gas. At low concentration, it can irritate the eyes and acts as a depressant. Hydrochloric acid. Exposure to the gas irritates mucous membranes of the eyes. Both gases can irritate the respiratory tract and during long exposure can lead to pulmonary edema. Hydrogen fluoride. Fluorine is a pale yellow gas that attaches to fine ash particles, coat grass, and pollutes streams and lakes. Exposure to these powerful caustic irritants can cause conjunctivitis, skin irritation, bone degeneration, and motting of teeth. Volcanoes release between about 180 and 440 million tons of carbon dioxide. A colorless and odorless gas, breathing air with more than 3% carbon dioxide can quickly lead to headaches, dizziness, shortness of breath, sweating, and general restlessness. At mixing ratios exceeding about 15%, carbon dioxide quickly causes unconsciousness. Aside from volcanic gases, you can also expect a lava flows during volcanic eruption. It is a streams of molten rock that pour or ooze from an erupting vent. Lahar is an Indonesian term that describes a hot or cold mixture of water and rock fragments flowing down the slopes of a volcano and river valleys. When moving, a lahar looks like a mass of wet concrete that carries rock debris ranging in size from clay to boulders more than 10 meters in diameter. Picture on the right is the village of Lourdes, built on lowlands 15 miles northeast of Mount Pinatubo, was inundated by giant fast-moving mud flows of volcanic debris, or lahars, in the months following the volcano's cataclysmic June 1991 eruption. Lahars have destroyed the homes of more than 100,000 people in the area surrounding Pinatubo. Another negative effect is volcano landslides. Landslides are large masses of rock and soil that fall, slide, or flow very rapidly under the force of gravity. These mixtures of debris move in wet or dry state, or both the landslide may transform into a lahar and flow down the valley more than 100 kilometers from a volcano. When volcanoes erupt energetically, they eject pulverized rock, lava, and glass fragments from the vent. The particles produced are called pyroclastic materials. Pyro means fire, clast means fragment, and are also referred to as tephra. These fragments range in size from very fine dust and sun-sized volcanic ash, less than 2 millimeters, to pieces that weigh several tons. So this is volcanic ash. Its particle size is less than 2 millimeters. This is our sample picture. We have lapilli. Its particle size is between 2 millimeters and 64 millimeters. This is our sample picture for lapilli. And volcanic bombs, this one. Volcanic blocks. And its particle size usually are more than 64 millimeters or 2.5 inches.
Wait, I'm quite confused. Why do people decide to live near the volcano despite its danger?
Well. Even though volcanoes are dangerous, people still choose to live near the volcano because of the positive effects. This includes tourism, fertile soil, geothermal energy, provide habitat to pioneer species, hull of the earth, and minerals. Now that you know the positive and negative effects of living near a volcano, still, at the end of the day, it's your decisions that really matter, whether you prefer to live near a volcano or not. We must always remember that we are responsible in our own decisions. Hanggang sa muli!